Assalamualaikum warahmatullahi wabarakatuh and good morning everyone. So today, my group will be presenting task 1 for subject teaching and assessment of measurement, geometry, statistic and probability, MTES 3273. Before we start our presentation, let us know our team member first. First one is me. My name is Nurul Ainadira bintu Muhammad Nasri, and second member is Nur Aliana Suha. Third member is Nur Shamimi Batrisha. Geometry is an important area of mathematics because it helps pupils develop spatial awareness, visual reasoning, and logical thinking skills. Through geometry, pupils learn how shapes are related and how to analyze their properties. However, many pupils experience difficulties when learning geometry. These difficulties often lead to misconception, especially when pupils depends mainly on visual appearance rather than understanding the mathematical properties of shapes. Therefore, in this presentation, we will discussing the issue of shape classification error, 2D and 3D misconception, and angle misconception. Here, we'll be explain why this misconception occur and suggest several strategies that teachers can do to use to improve pupils' understanding. Next, in primary mathematics, pupils are introduced to various geometric shapes and are expected to classify them based on their properties. For example, pupils learn about quadrilaterals such as square, rectangle, parallelogram, and trapezium. Ideally, pupils should be able to analyze shape by examining their characteristics such as the number of the sides, right angle, and parallel lines. However, in many cases, pupils mainly focus on how a shape looks instead of analyzing these defined properties. As a result, they may memorize shape visually without developing a deeper conceptual understanding. This situation often leads to the shape classification error, which is the main issue highlighted in these presentations. Shape classification refers to the process of grouping geometric figures based on shared mathematical properties. For instance, rectangle have 4 right angles, while parallelogram have 2 pair of parallel sides. Square share properties of both rectangle and rhombuses. Because of these shared properties, shape can actually belong to more than one category at the same time. However, many people do not recognize this relationship. Instead, they tend to treat each shape as a complete separate categories. This misunderstanding indicates that pupils may not yet understand the structural relationship between geometric shapes. Next, one important idea in geometry is the hierarchical relationship between quadrilateral. For example, every square can also be classified as a rectangle because it has 4 right angles. Similarly, rectangle belongs to the category of parallelogram, and all parallelogram are quadrilateral. This means that geometry shapes are organized within a classification hierarchy where one shape can be part of a larger group. However, many pupils fail to recognize this relationship. Instead, they believe that square and rectangle are entirely different shapes. This misconception shows that pupils may understand the shape individually, but they struggle to see how these shapes are mathematically connected. Next, after reading and research several trusted resources, we find that several misconceptions commonly appear in the classroom. One is the common example is when pupils believe that a square cannot be considered as a rectangle. This often happens because pupils think that rectangle must have 2 long sides and 2 short sides. Another misconception occurs when shapes are rotated or tilted. When pupils see a rectangle placed diagonally, they may not recognize it as a rectangle because it does not look like a typical example shown in textbook. They recognize it as a diamond. In addition, pupils often classify shape based only on their visual appearance rather than analyzing properties such as angle, sides, and parallel lines. Next, how do we know this misconception appear? So, we can find this misconception in the classroom or the student worksheet that have been done. So, This evidence of this misconception can be observed from pupil classroom work. When pupils are asked to identify shape from a group of figures, many of them struggle to recognize shapes that appear in different orientation. One reason for this problem is prototype thinking. When pupils recognize only the most familiar form of the shape, another reason is a limited understanding of geometric properties. Without a strong understanding of concepts such as right angle and parallel sides, pupils may find it difficult to analyze shape correctly. So, to support our discussion, this issue can be explained using the Van Heel theory of geometric thinking. According to this theory, pupils develop their understanding of geometry through several levels. Most primary school pupils are at the first level or the zero level, known as visualization, where they recognize shape mainly based on how they look. And at this level, pupils may struggle to identify shape correctly if the shapes are rotated or present differently. To improve their understanding, pupils need to progress to the next level, which is the level 1, where they begin analyzing shape based on their mathematical properties. As a teacher, we must know about this topic and acknowledge it to know that how this issue can impact our student. So if these misconceptions are not addressed, they can negatively affect this learning in several ways. First, pupils may develop a weak understanding of how geometry appear are related to each other. And the second, their ability to reason logically about geometric concepts may remain limited. Finally, these difficulties may create challenges when pupils encounter more advanced geometric topics in higher level of education. Next, as a teacher, we can overcome this misconception using several effective strategies. The first strategy is to present shape in different orientation or using the hands-on learning materials. So pupil learns that they identify a shape does not change when it's rotated. The second one, teacher can also organize shape sorting activities where pupils classify shape based on their properties rather than their appearance. And the last one is the use of manipulative and digital tools such as geoboard, shape cards, and dynamic geometry software like GeoGebra. It can help pupils explore geometric relationship more effectively. Lastly, for my part, for the conclusion, shape classification error are a common issue in primary geometry learning. This misconception often occur because pupils rely on visual appearance instead of analyzing the defined properties of the shapes. By identifying this misconception early and apply appropriate teaching strategies, teachers can help pupils develop stronger geometric reasoning and a deeper understanding of geometric relationship. Next, I will pass this presentation to Nur Shamimi.
Hi and Assalamualaikum. My name is Nur Shamimi Batusha binti Muhammad Radwan, and I will continue to present about second issue, which is the 2D and 3D confusion. Let's have a look at the first misconception example, which is a cube is a square. Many pupils believe that a cube is simply a square. This misconception happens because pupils only see the front face of the cube, which is a square, and ignore the other dimensions. However, the correct idea is that a square is a 2D shape with area only, while a cube is a 3D solid with faces, edges, vertices, and also volume. Therefore, a cube is not a square, but a solid object composed of 6 square faces. Another misconception occurs when pupils think that a triangle and a triangular pyramid are the same. This happens because both contain triangular shapes. However, a triangle is a 2D shape, while a triangular pyramid is a 3D solid. So a triangle is a flat and only has length and width, while a triangular pyramid has length, width, and height. It also occupies space and has volume. This shows that pupils may recognize shapes, features superficially, but still lack a clear understanding of dimensional structure. So, what is the difference between 2D and 3D shapes? So, first of all, two-dimensional shapes have length and width only, exist on a flat surface, and examples include square, triangle, and rectangle. Meanwhile, three-dimensional shapes have length, width, and height. They occupy space and have volume. An example is include cube, pyramid, and sphere. Understanding these differences help pupils develop correct spatial and geometric reasoning. So, why does this misconception happen? First, over-reliance on visual appearance. Pupils often identify shapes by what they look like, not by their properties. Second, limited spatial reasoning. Pupils may find it difficult to imagine how a flat drawing represents a solid object. Third, teaching focused on naming rather than understanding. Sometimes, lessons emphasize recognizing shape names without exploring their dimension, shapes, edges, and vertices. And fourth, lack of hands-on experience. Without manipulative or real object, pupils may struggle to connect diagram with actual solids. From a theoretical perspective, this misconception can be explained using a Van Hill's theory of geometric thinking. According to Van Hill, pupils develop geometric understanding in stages. So at level 0, pupils visualization, which is pupils recognize shapes based on their overall appearance. And at level 1, analyze, which is pupils begin to identify properties such as faces, edges, vertices, and dimension. The confusion between 2D and 3D often happens because many pupils are still at the visualization level. They recognize shapes by how they look, but they do not yet analyze the properties that make 2D and 3D shapes different. Research also supports this issue where Van Hils explained that pupils at the visualization level identify shapes by appearance. Fujita 2022 found that weak spatial reasoning make it difficult to interpret 2D drawing of 3D shapes. And Naziri 2022 reports that primary pupils commonly show misconception in classifying geometric shapes. And overall, studies show that pupils often confuse 2D shapes and 3D shapes because they rely on visual appearance rather than geometric properties. This slide shows the conceptual framework. Understanding 2D and 3D shapes begin with an instructional approach. Then pupils gain spatial experience such as using manipulative, real objects, nets, and models. This leads to dimensional understanding, including length, width, height, and the difference between flat and solid shapes. As a result, pupils can achieve correct shape classification, which then improve their geometric reasoning. If pupils have limited spatial experience, they are more likely to develop misconception about 2D and 3D shapes. Let's look at strategy 1 on how to improve their misconception. Okay, so the first teaching strategy is using real 3D objects. So teachers should bring real objects into the classroom, such as boxes, balls, cans, cones, or pyramids. So pupils can touch the objects, observe the faces, the edges, and also the vertices, and compare the real object with the picture. This helps pupils to understand that 3D shapes are not just drawing, they are solids that occupy spaces. So the benefit of using real 3D object is that geometry learning becomes more concrete and meaningful. Pupils can directly experience the differences between the flat shapes and solid objects. Instead of relying on a visual appearance, they begin to notice important properties such as faces, edges, and volume. This improves spatial understanding and help reduce confusion between 2D and 3D shapes. The second strategy is using shape nets. Teacher can use nets to show how 2D shapes can be folded to form 3D solids. Activity may include folding a cube net, identifying which net can be formed a pyramid, and matching nets with the correct 3D shapes. This helps pupils connect flat representation with solid objects more clearly. So the benefit of using shape nets is that it strengthens pupils' ability to visualize how a solid is formed from a flat faces. It also helps them understand that 3D shapes are made up of 2D surfaces. As a result, pupils can better differentiate between a shape itself and the faces that form the solid. Okay, this support the development of spatial reasoning and dimensional understanding. The third strategy is error analysis. Teacher can present common wrong ideas, such as a cube is a square, a triangle and a pyramid are the same. A circle is the same as a sphere. Okay, then the teacher asks pupils questions such as, do you agree? What is the misconception? What is the correct explanation? Or which one is 2D and which one is 3D? This strategy encourages pupils to think critically and reflect on their own understanding. So the benefit of error analysis is error analysis help pupils identify why certain ideas are wrong, not just what the correct answer is. This deepens conceptual understanding and prevent repeated mistakes. It also creates a learning environment where misconceptions are discussed openly and used as opportunities for learning. As a result, pupils become more careful, reflective, and confident in geometry. Finally, in terms of assessment implication, teachers should not only ask pupils to name shapes, but teachers should also ask pupils to explain why a shape is 2D or 3D, describe the properties of the shape, compare a flat figure with a solid object, or justify their answer using correct mathematical language. This is important because assessment should measure reasoning and understanding, not memorization alone. So that's all from me. I will pass this presentation to Aliana Suha.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Aliana Suha binti Azrul Afendi, and I will continue this presentation on issue number 3, which is angle misconceptions. So let's start. Now let's get into how angle misconception happens. It happens when pupils form an incorrect understanding about what an angle is, how angle size is determined, or how angles should be identified and measured. Many primary pupils can name angles such as acute, right angle, and obtuse, but they do not actually understand the concept behind them. They often rely on appearance, line length, or memorize procedures instead of conceptual understanding. This means a pupil may get some answers correct by guessing or memorizing, but still hold a wrong idea about angles. So, how can we overcome these misconceptions from happen? Let me tell you the correct mathematical idea of an angle. An angle is the amount of turn between two rays that meet at a common point called the vertex. The size of an angle depends only on how wide the opening is between the two rays. And remember, the size of an angle does not depend on the length of the lines. The direction of the angle is facing, whether the angle is drawn big or small on paper. In this presentation, I will bring to you three main misconceptions happen. The first one, longer arms means a bigger angle. The second one, a different orientations means a different angle. And the third one is the wrong use of protector. The first misconception, longer arms means a bigger angle. Many people think that if the two lines forming the angle are longer, then the angle must be bigger. They focus on the length of the rays rather than the space between them. This happens because children often judge visually. A drawing with long rays may look larger than a drawing with short rays, even when the angle opening is exactly the same. Let's look at the picture given. Some says that angle B is bigger because their lines are longer. So why this is wrong? It is because the length of the rays does not change the amount of turn between them, so both angles are still 60 degrees. So the angles are the same. Move to the second misconception. A different orientation means a different angle. People often think an angle changes when it is rotated. For example, they can identify a right angle only when it looks like the corner of a square, standing upright. If the same right angle is tilted, they may no longer recognize it. They depend on the prototype image of an angle instead of understanding its properties. So here is what they should remember. Rotation does not change angle size. A right angle remains 90 degrees no matter how it is turned. The third one is wrong use of protector. Many people use the protector incorrectly because they do not fully understand how angle measurement works. The most common mistakes are placing the center of the protector away from the vertex, not aligning one arm of the angle with the zero line and reading the wrong scale. People may know how to hold the protector but does not fully understand where to place it, which scale to read, how to check if the answer makes sense. So let's look at the example. So let's look at the factor on why do these misconceptions happen. The first one, over-reliance on visual prototypes. Teachers and textbooks often show angles in standard positions only, so that pupils memorize appearances instead of understanding attributes. The second one, limited hands-on experience. If pupils only see angles on worksheets, they may not connect angles to turning, movement, and real life. And the third one is weak mathematical language. Pupils may hear terms like acute and obtuse, but not understand words such as degree, vertex, turn, and rays. And the last one is teaching procedures before concepts. Sometimes pupils are taught how to use a protector before understanding what angle size means. So these are all the factors that might cause the misconception happening. Now let's look at the effect on students' learning. The first one is weak geometric reasoning. When pupils misunderstand angles, they cannot think carefully about angle properties or compare angles correctly. They are fully rely on how the angle looks than on the actual opening. The second one is poor angle classification. Pupils may struggle to identify whether an angle is acute, right, or obtuse angle because they focus on appearance instead of a degree measure. The third one is inaccurate measurement. If pupils use the protector wrongly, they will record the wrong angle measurement. This will affect their answers in geometry tasks. And the last one is Reduce confidence. When people keep making mistakes in identifying or measuring angles, they may feel confused and lose confidence in geometry, and the people becomes afraid to answer angle questions because they are unsure. As a teacher, we must tackle a strategy to teach the students. The first strategy is to teach angle as an amount of turn. Instead of giving definitions only, the teacher should help pupils understand that an angle shows how much something turns. The teacher can also use clock hands to show turning from one position to another. Besides that, scissors can be used to show how the angle changes when they open and close. A door is another useful example because pupils can clearly observe different amounts of opening which represent different angles. This strategy is beneficial because it makes the idea of angle more concrete and easier to understand. Pupils will see that an angle is not just a shape on paper but a measure of turning, and as a result, they can identify and measure angles more accurately and avoid common misconceptions. The second strategy is to use manipulatives. People should build and move angles physically using materials such as 2 straws and a paper fastener, ice cream sticks, hinge cardboard strips, or angle maker tools. This strategy helps people understand angles in a concrete and hands-on way, so they can clearly see that changing the length of the arms does not change the amount of angle. This is useful in correcting the misconception that bigger looking diagrams always show bigger angles. Manipulatives also make learning more engaging and help visual and kinesthetic learners understand the concept more clearly, and as a result, pupils gain a stronger and more accurate understanding of angles. Now let's look at the third strategy, which is to use error analysis. In this strategy, the teacher shows a wrong answer on purpose and asks pupils to identify the mistake. For example, the teacher may say, "This angle is bigger because its lines are longer." Then, the teacher asks questions such as, "Do you agree? What is the misconception here?" The teacher can also show common mistakes happen when using a protector and ask pupils to correct them. This strategy is effective because it helps people recognize misconceptions directly. They do not only learn the correct answer, but also understand why certain ideas are wrong. This deepens understanding, prevents repeated mistakes, and helps people see that mistakes are part of learning. This issue can be related to 3 learning theories, which are Van Hill theory, constructivist theory, and Piaget cognitive development theory. The first one, Van Hill theory, explains that pupils learn geometry in stages. At the early stage, they usually recognize angles based on how they look, not based on their properties. This is why some pupils think a rotated right angle is not a right angle, or believe that longer rays make a bigger angle. The second one is constructivist theory. It shows that pupils learn best when they actively build understanding through experience. If they only memorize angle names or protector steps, misconceptions can easily happen. That is why hands-on activities such as using straws to make angles are very helpful. The third one is Piaget's theory. It is also relevant because primary pupils are mostly in the concrete operational stage. This means they understand better when they use concrete materials and visual examples rather than abstract explanation only. Overall, these theories show that angle misconceptions happen when pupils rely too much on their appearance and do not get enough meaningful hands-on learning experiences. Here are the suggested classroom activity called Straw Angle Exploration. In this activity, each pupil is given 2 straws joined with a paper fastener to make an angle model. Pupils move the straws to form acute, right, and obtuse angles, then compare angles with different arm lengths. This activity is effective because it makes learning hands-on and concrete. It helps correct the misconception that longer arms mean bigger angles, and it allows people to identify angles in a more meaningful way. It also encourages discussion and reasoning among pupils. So to conclude, this presentation shows that shape classification errors, 2D and 3D confusion, and angle misconceptions are not just small mistakes, but they reflect deeper misunderstandings in pupils' geometric thinking. If teachers do not address them early, these misconceptions can continue and affect pupils' confidence and achievement in mathematics. Therefore, teachers need to be more aware of these issues and use effective strategies to guide pupils towards the correct concepts. With proper support and meaningful learning experiences, pupils can build stronger geometric understanding, think more critically, and become more confident learners in mathematics. So that's all from our group. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.